Imagine a power source so colossal, so mind-bendingly energetic, that it's literally raining inside a planet the size of a small star. Far beneath the swirling cloud decks of Jupiter, Saturn, and many gas giants across the galaxy, something extraordinary is happening. Droplets, yes, droplets, of metallic helium are falling like rain. But this isn't normal rain. This is helium, one of the lightest elements in the universe, condensed under crushing pressures into an exotic, metallic fluid that sinks through the planet's interior like molten diamonds falling through quicksand. Today, we're going to explore one of the most extreme and futuristic energy ideas humanity has ever conceived: helium-rain power reactors. A technology that harvests the literal weather of gas giants and converts it into nearly unlimited clean energy. To understand how we even get to this level of insanity, we need to break down the physics. Gas giants aren't just big. They're enormous pressure factories. In the upper atmosphere, helium floats freely as a gas, mixing with hydrogen. But dive deeper, and pressure skyrockets to millions of times Earth's atmospheric pressure. Temperature soars to tens of thousands of degrees. Under these conditions, helium stops behaving like helium. It becomes metallic. It turns into a liquid metal. And just like dense, heavy substances do, it sinks. This metallic helium descends towards the planet's interior, releasing massive gravitational potential energy as it falls. Think of it like rainfall, except each droplet is a tiny bomb of energy formed by the weight of a planet pressing down on it. Gas giants have been doing this for billions of years. And according to astrophysicists, that's a big part of why planets like Saturn emit far more heat than they receive from the sun. They're powered from within, and helium rain is one of the engines. Now imagine sending machines into that environment. Not rockets. Not satellites. Specialized autonomous drone-submersibles designed to dive into a gas giant's atmosphere and tap into the helium rain itself. These machines would look nothing like conventional spacecraft. They'd be built like floating fortresses, part submarine, part reactor, part fusion-powered glider. They would enter through the upper cloud layers, riding hydrogen currents downward like surfers on a cosmic storm. And there, deep inside the crushing, twilight layers of a world like Saturn, they'd deploy magnetic funnels, vast electromagnetic nets that catch helium droplets as they form and fall. Each metallic helium droplet carries energy not because of its chemical makeup, but because of the absurd gravitational potential difference between where it forms and where it wants to fall. When a drone intercepts that fall, it's capturing energy in the same way a hydroelectric dam captures the flow of water. Except instead of a river, you're bottling the gravitational collapse of planetary matter. The drone channels this energy into internal generators that convert falling metallic helium droplets into heat, electricity, or fuel. Each droplet might release megajoules of energy. Millions of droplets per second create a power flow greater than Earth's largest reactors. And this is just one drone. But here's the real magic: helium rain can be continuously harvested. Gas giants have effectively infinite supplies of helium forming at depth, mixing, separating, and falling. It's a self-regenerating engine. The drones wouldn't dig in or strip the planet's resources. They'd tap into a natural process, like placing a turbine inside a river that never stops flowing. And unlike burning fuel, helium rain is clean. No radiation. No pollution. Just pure gravitational energy converted into usable power. So what could we do with this power? On board, the drones would need it simply to survive. The deeper you go into a gas giant, the more the environment tries to kill you. The pressure is high enough to crush steel. The electrical storms are bigger than Earth itself. Magnetic fields can fry electronics like popcorn kernels in a microwave. But if a drone is powered by the very rain it is harvesting, it lives off the planet. It becomes self-sustaining. And if it can harvest more energy than it needs to operate, it can beam that energy outward using giant microwave or laser transmission arrays. Picture this: a fleet of helium-rain drones floating deep inside Saturn, harvesting the metallic stormfall, converting it into beamable energy, and sending that power upward to orbiting collectors. In orbit, massive ring stations capture the incoming energy and store it in superconducting batteries or convert it to more stable fuels like hydrogen-helium plasma. These orbital collectors then beam the energy onward, across millions of kilometers, to power stations near Earth or Mars. This creates a solar system-scale energy grid. Earth and Mars continue using solar, wind, fusion, and geothermal locally, but when long-term power is needed, when colonies in the outer solar system want steady energy even when far from the sun, beams from helium-rain reactors keep the lights on. It is essentially space hydroelectricity. You harvest gravitational storms in one world and fuel civilization in another. So let's talk logistics. Could we actually build a machine that dives into a gas giant and survives? The idea is science fiction for now, but physics doesn't say impossible, it just says really, really hard. A helium rain harvester would need walls made of ultra-dense alloys, likely carbon nanotube composites mixed with exotic metallic glasses. It would be protected by plasma shields that deflect lightning. Artificial magnetic fields would repel crushing pressure by maintaining a cavity of stable plasma around the hull. It would glide like a submarine through liquid metallic hydrogen, a material so conductive it behaves like a superfluid battery. Nothing in human engineering compares to this, but nothing in human engineering says we can't get there. And the AI running these drones would be unprecedented. They would need to think faster than any pilot or computer on Earth. They'd analyze storms the size of continents in real time. They'd calculate gravitational gradients, pressure fronts, helium droplet densities, and magnetic field distortions every second. They'd need predictive foresight on par with weather simulators running at quantum processing speeds. Humans wouldn't fly these drones. They would issue mission goals, and the drones would handle the impossible details themselves. Now, what about the economics? Why bother with a gas giant power plant when we have fusion? The answer is scale. Helium-rain reactors tap into the gravitational energy of a planet 1,000 times more massive than Earth. You're not burning fuel, you're exploiting planetary evolution. Even the most advanced fusion reactor on Earth will pale in comparison to the raw, internal heat flow of Jupiter or Saturn. Fusion is a matchstick. Helium rain is a volcano. If humanity becomes a Type 2 civilization, one capable of harvesting energy from planets and stars, we need stepping stones. Dyson spheres are too far in the future, too complex, too massive. But helium-rain reactors? They are a bridge. They're a way to learn how to build machines that work with planetary forces instead of against them. They're a way to power colonies in the outer solar system without depending on sunlight. And most importantly, they're a way to begin tapping into the colossal energy budgets of worlds beyond Earth. But there's something even more incredible. Helium rain might not be unique to Jupiter and Saturn. Exoplanet research suggests that many distant gas giants, some far larger and hotter than anything in our solar system, experience even more extreme versions of the process. On super Jupiters, with higher gravity and hotter cores, helium rain could fall in thick metallic torrents, releasing monstrous amounts of energy. A helium rain harvester stationed above such a world could theoretically generate more power than all energy sources on Earth combined. It would be humanity's first true interstellar power farm. Of course, there are ethical and political questions. Who owns the energy inside a gas giant? Who controls the drones? Who decides how much power is harvested and how it's distributed? Could a nation or corporation monopolize a planetary energy source? These are questions every future space-faring civilization will face. But as with all great innovations, humanity must weigh risk against potential. Helium-Rain Power Reactors represent a vision of a future where we don't just observe the universe, we participate in it. We don't just look at planets, we tap their physics. We don't just survive, we thrive on cosmic processes older than the solar system itself. The idea seems insane now. It sounds like the fever dream of a sci-fi writer on an energy drink bender. But so did nuclear power in 1900. So did the idea of harvesting solar power from space. So did the idea of machines flying through space and landing on other planets. Our ancestors harnessed rivers. We harnessed atoms. Tomorrow, we may harness rain, not from clouds of water, but from the metallic heartbeats of gas giants. And in doing so, we could unlock an energy era worthy of a species destined for the stars. If you're ready for the next level of humanity's cosmic future, helium-rain power reactors might just be the beginning. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.